Hi, everybody. Welcome to session 111, NSImage and Leopard. My name is Ken Ferry. I'm an engineer in the Cocoa Frameworks group. So today we're going to talk about NSImage. Why is this? Because we've done a lot of work on it for Leopard, and we think you'll like what we did, so we'd like to tell you. We've tried to make it simpler, more consistent in terms of behavior. We've tried to improve its performance, and we've also improved the integration with other frameworks on the system. In particular, the integration with Quartz is much tighter, and with CGImage in particular, if you're aware of that is. And if you're not, we'll get to it. OK, so the first part of the talk is going to be about the changes that we've made for 10.6. In order to do that, we're going to need to talk about the core architecture of NSImage. So let's get going on that. One thing I want you to keep in mind, usually when you think of an image, you're going to think of something like this. A photograph, say. This is a photograph my father took. Pretty nice, I think. However, for the purposes of this talk, we also want you to keep in mind images of this sort. These are interface images that the user would not necessarily think of as images, icons and such. The distinction might be the images that you own versus the images that your user owns. And it turns out that just these sorts of images have somewhat different issues associated with them. So keep both in mind. All right, so if there's one thing that an image is good for, it's drawing. So let's just run down and see what happens when you ask an image to draw. What is the sequence of events, OK? So suppose you have something like this Pages icon, all right? The first thing to realize is that even as a user, you might be aware that the Pages icon is available in multiple sizes, OK? There's a 16 by 16, a 32 by 32, 48, all the way up to 512 by 512, different bitmaps associated with it. And that's reflected in the API. So NSImage itself is actually a container for what we call NSImage reps. And in this case, there's going to be one rep for each of these different size bitmaps associated, OK? And we'll discuss NSImage rep a little bit more later. Anyway, when you're asked to draw, what happens? Well, you have a location that you're going to draw in. It's called NSGraphics context. There's a rectangle in the context. We look at that rectangle. We select the best representation, and we draw it. OK? We'll fill this picture out a little bit more later, but even that is enough to start talking about some differences. In 10.5, this was the name of the method that did the representation selection. In 10.6, it's a little bit different. It takes more arguments. So there was just one argument in 10.5, device. This was a dictionary. Okay, it describes something like a window. It would say, like, this is 8-bit, and it's RGB, something like that. In 10.6, we take these three arguments, a rect, a context, and hints, which is a dictionary. Let's discuss what those are. All right? Well, the rect is the rectangle where the image is being asked to draw. The context is this drawing location. It's this object that encompasses it. And it includes information such as what is the relationship of the units that the rect is in to pixels. That's information that's in the context. Okay? And that's exactly the information that is required to pick the most appropriate size bitmap for that Pages icon, okay, just for one example. There's other information that might be in there, such as whether it's gray, maybe if you're printing, or 1-bit if you're faxing or something like that. So, and all of these things can play into which representation is most appropriate. And the main thing to realize is just focus on this rect. Oh, I didn't say what the hints was. Where the hints are sort of extra information that you can provide. It's optional. And it can also be used to override aspects that we would otherwise infer from the context. And I want to just point out, just ask you to look at this again, because it's going to keep coming up. This rect context hints triple is going to be key in all the new APIs. Okay? Anyway, that's the information we need for representation selection. Just the dictionary before was not good enough. So how did it work? Actually, it was using an internal method before in 10.5 for actual representation selection. Okay, so let's fill out that picture a little bit more. Something else that NSImage will do when it's being asked to draw is it will cache. OK, great. What's the point? The point is that if you're asking the image to draw repeatedly to the same destination, then we can render this hopefully optimized object, which can be drawn down to the context faster repeatedly. And the reason I wanted to bring this up is, surprise, there are changes. This caching business was a little bit confusing in 10.5 because there are a whole bunch of different methods that you could set on this image that had to do with caching. And unfortunately, they affected more than just performance. Some of them would affect even things such as where the image would end up drawing, how much of the screen it took up. And that's not really how we want caching to work. In 10.6, hopefully, it'll just be a matter of something you can't even tell if it's there unless you're using instruments to profile it or unless it's so slow that your user can tell. And this is part of what I mean by making it simpler and behave more the way you expect it to. So these are all methods that are defined on NSImage that help control caching, and they're all deprecated. And they're deprecated without replacement. And it's not that functionality has been removed. It's more like it's just not necessary anymore because we are doing a better job of invalidating the cache on our own, and we don't need as much advice about how to do it. OK. So there's still more changes in caching. One change that is mostly an implementation detail, but it leaks out in a few places, is that in 10.5 and earlier, we would cache to an off-screen window. OK, it sort of makes sense in that if you're drawing to a window, maybe it makes sense for your cache to be some other window. OK, it seems like it could make sense. But there are a couple ways in which that's non-optimal. It's kind of heavyweight. Windows turn out to be a scarce resource, sort of like file descriptors. And as our apps get bigger and more complicated, the fact that you could run out of windows was a problem. And when you do run out of windows, it's fairly dire. The system does not do very well. So that's hopefully not going to happen anymore. And also, it's just rather bigger than it needs to be. The CG image, which is a quartz type, is a very good representation for a cache for us. So we're going to do that. OK. So there was a class that represented the drawing that was backed by a window, NSCached_ImageRep. OK? You see it has a method window and rect. That's the rect within the window where the image is cached. So that whole thing has to be deprecated, which is fine. It still works, but we're not going to use it internally, and we would suggest that you not use it in your own apps going forward. OK. And the business with the CG images is that you'll see, but they're being used all the way throughout the AppKit internals now in hopefully an optimal way. And part of that is that we're going to be able to supply one of our most common feature requests for NSImage, which is I want to take this NSImage and I want to get a CG image out of it. For those that OK. I was going to explain why you might want this, but apparently you guys know. I'm still going to say. So why would you want this? Mostly because you're interacting with other APIs that deal in CG images. That's the most common reason. One of them, for example, but we're also taking care to try to make more APIs take NSImages. As you'll see in the talk, that's appropriate. CA layer, for example, in 10.6 actually can directly take an NSImage as its contents. You don't need to get a CG image for that. But that aside, we're still making it easier to extract CG images. And we're also making it really easy to take a CG image and represent it as an NSImage. That's the second method, image with CG image size. That wasn't super hard in Leopard, and that was certainly much easier to implement. But nevertheless, it's extremely easy now in Snow Leopard. However, usually when people want to get the CG image, they want a method called CGImage on NSImage. And this one takes 3 parameters. So that's not quite what people want. So why did we do that? Well, the problem is that a CG image just is not capable of capturing all the information that's in an NSImage. OK? And so we need to know more to give you a CG image. That the CG image is just a flat bitmap. OK? It's not going to be able to represent those. For example, in this case of these sizes, this pages icon that's available in multiple sizes, it's not going to be able to represent all 3 at the same time. Another example is that an NSImage can be backed by a PDF, OK, or a window, the way we were showing before. And the CG image is not going to be able to do that, to preserve all of that information. So what it can do instead is, I've been calling it a snapshot. Think of, it's just a flat bitmap, so I'm 3-dimensional, OK? And you can't represent me, all the visuals that I encompass as a single flat 2D image. However, if you fix the camera angle that you're looking at me in and fix a box that you're trying to look at, then you can produce a 2D image which represents me from that angle and is an accurate reproduction. And that's what the CG image is going to be. So when you pass a rect and a context and this hints thing, then you're going to be able to get a CG image which, if you draw it in the same rect as you passed in that context, would be the same as the NSImage drawn in that rect in that context. Okay? So it's sort of like the image from an angle. Okay, so that's the CG image. There is one sort of unfortunate little tweak to that, which is that the rect that we pass in is not actually a rect, it's a pointer to a rect. And let's see why that is. OK, suppose that the rect that you're passing in is not pixel aligned in the context, all right? So these lines are supposed to represent where pixel boundaries are, and this is the rect that we're actually drawing. And suppose the NSImage is actually just backed by a PDF. Like I said, NSImage can be vector-based. So if it's just drawing, it's just going to draw. You can render a PDF into a rectangle that has nothing to do with pixels, and that's fine. However, if you want to get a CG image for this, there's going to be a bit of a problem, because we can't give you something that's some fractional number of pixels wide. We would have to give you something that's, what we can do is we can give you something that covers this larger rectangle in the context that is pixel integral, okay? And we can fill our own drawing into that and hand you back a CG image which is an appropriate snapshot of that larger rect. So how does this end up working? It sounds a little harder to explain, I think, than it is in practice. But the deal is that if you pass this rect to the method, and when it comes back, if you draw the CG image in the rect you get out, that's the same as if you had drawn the NSImage in the rect that you passed in. Okay? Whatever. It works okay in practice, I think. All right. Okay, so that's fine, except you might say, well, that's great. I understand why you need all these parameters, but sometimes I don't have an NS graphics context. I need to make one of these I need to get out one of these CG images at a time when I'm not drawing. Do I expect you to make an NS graphics context? No. These are acceptable parameters for all three arguments, null, nil, nil, so that's perfectly straightforward. And it's just that they each have a defined meaning. All right, what do they mean? Well, null is pretty much going to mean that you pass the most natural rectangle you could possibly draw the image in, maybe, I don't know, if you think there is such a thing, which is the origin 0, 0, and then the size of the image. And then there's this tweak business about pixel integral, which I'll explain in a second. And nil for context means we're just going to assume it's as if you had made a window on the main display in the most natural way. That's the kind of context it's going to be. And the reason we even say things like main display is that impacts things like color space, because the different displays can have different color spaces. And hence nil, that's a little bit more obvious. I mean, it means you didn't provide any extra information. And now if I go back, and what's this business about the pixel integral thing? It just means that the CG image that we're going to pass back to you will never have any of that padding on the outside, like I was just saying. Instead of getting that padding, what you might get instead is that there might be some anti-aliasing artifacts, because we might have had to inflate the rect a little bit from what you passed us. And anyway, regardless, that's what that is. Okay, and I really did just want to emphasize this contract, because it's the one really important thing about the API, okay? Drawing the CG image in the rect you get out is the same as drawing the NS image in the rect you pass in. And you know nothing else about the CG image. So for example, suppose you had an NS image which was natively just backed by a single CG image, okay, that really is, all of its data is encompassed in just a single CG image. Well, then that CG image is always going to be a valid return from this method, no matter what rect, no matter what context you pass in, because it does entirely encompass all of the information of the NS image. So in particular, even if you pass a 3 by 3 rect, you might get back a 27 by 27 CG image. You can't tell. But this is what you can tell, that it does capture the drawing of the NS image. Okay, so all of this talk of snapshotting and caching and rendering PDFs in business, is this starting to sound expensive? I don't know, maybe. But I'd like to say that it's not, that it's only going to be doing work in the cases where you would want the work done, and a lot of that is because I haven't showed you all the API yet. There's also, the same method has been added down at the NSImage rep level, CG image for proposed rect, context, hints. All right. And what is this going to do? Well, to do that, let's go ahead and now talk about exactly what NSImage rep is. So NSImage rep, the really distinction between NSImage rep and NSImage is that NSImage rep is built for subclassing, very, very similar to NSView. Okay? In the app kit, we have a bunch of different classes, and each of them represents the way it works is you just override the draw method, and you produce the drawing, whatever it is. So in the case of a bitmap image rep, it's going to draw the bitmap. In the case of a PDF image rep, we override draw, we draw the PDF. In the case of an NSCI image rep, that's like a core image. We override draw, and we'll just draw that. This cached image rep, I told you that represents drawing back by a window, and it's deprecated, but but it's still there. So, okay, yeah, and it's there to be subclassed. If you think about NSView, most people have subclassed in NSView, or at least they're aware it's pretty easy. The one method you really have to override is draw rect, and in that method, you're drawing into the view's bounds. That's the location you're filling. NSImage rep is the same way, except you override draw. That's the only method you really have to. and the rectangle you're filling is 0, 0 image size. That's it. Okay, that's all you really have to do. And it's worth pointing out because NSImage doesn't look like it's that easy to subclass. It has all these other methods that you look at and you say, I don't know how to implement these. Things like color space name, bits per sample, pixels wide, pixels high. Okay, well, the thing to understand about those is that they're used for representation selection. Okay, these are best effort methods. When you say color space name, what you're saying is, this is a good color space for me, all right? Or with the pixels wide, it's saying, if you're drawing into something that's this many pixels wide, please choose me. Okay, which means, and if you don't, so that's interesting both from a subclassing point of view and also as a caller's point of view, to realize that despite the names, these aren't, shouldn't necessarily believe these things because they're only best effort. Though in the case of something like a bitmap image rep, yeah, it's definitely in our contract that pixels wide has to be the actual number of pixels in the bitmap. Okay, and yeah, and they're optional, so you don't really have to do it. Later in the talk, I'm going to show you an example of subclassing in NSImage rep. You'll see how easy it is. Okay, but the whole point of this is I want to talk about this other new method we added, the CGImage proposed rect context hints. Okay, and the deal is that you can override